All right, good morning, everybody, and welcome to another live stream. We are finally getting back to our Summer of Rag series, and I think we are just gonna make it officially to the official end of summer for the summer rag. I know a lot of people consider the starting of school to sort of be the end of summer, and as well as I do, but yeah, I'm a little bit behind on the series, but we are going to see it to completion. And so just to recap what we've covered to date, because this is going to be building off some of the stuff that we've covered before. So we've covered what retrieval augmented generation is at a general level. We built a very simple RAG pipeline in a previous stream. We demonstrated how we could use RAGs to evaluate the results. And so now we're going to move into some more advanced things. And so this is sort of going to be like part 1 of 2 of the advanced stuff. So part 1 here, we're going to cover things in terms of ingestion of your documents into something like a vector database. And then in the next one, we will cover how best tactics around retrieving stuff out of the vector database. Now I will say, from what I see, it looks like more of the optimization and the advanced stuff comes from the retrieval side, actually. So there's actually less that I found that you could do in terms of ingestion for optimization, but we will cover those things today. And this is going to be a little bit of a 2-for-1 stream. So if you all are popular, following X out there or whatever, you may see a lot of people getting really riled up about, in a positive way, about the new Cursor IDE. So if you're not familiar with what Cursor is, it is a fork of VS Code, and it is basically an IDE that is designed all around AI coding assistant. So this is it is a step beyond GitHub Copilot, I would say. So GitHub Copilot, I still think it's pretty good. But Cursor, I think the biggest advantage that it gets is it takes in context your full entire code base, whereas I think GitHub Copilot only looks at the single file that you're working in. Now, I kind of expect that GitHub Copilot is going to see some sort of update that'll probably do that in the future. But anyway, we're going to demonstrate Cursor. I'll tell you. Well, I'll get into it later, but I'm going to tell you what I do about Cursor and why I'm probably not going to stick with it, and it has nothing to do with Cursor, actually. Okay, so let's go ahead and share my screen here. Let's start off with some imports here, and then we'll get into we'll refresh you on some of the data that we're working with as we get to it. So a lot of these imports here are the exact same from things that we used before. So you might recall that we use RAGs to actually evaluate our stuff, but that we had to actually transform our data into a Hugging Face data set in order to be able to use RAGs. So all this here is nothing new. I guess I do want to call out 2 new things here. And so the first one I want to call out is FAISS. I can't remember what this stands for, but basically Facebook made their own, or Meta, I guess, made their own vector search algorithm thing that you can use as a vector database from LangChain. So we did use Chroma in a previous stream. And the reason that we're not using that for this stream is, so I was doing my work all in a Kaggle notebook, and something got updated to where basically it just Chroma was not working in a Kaggle notebook anymore. I don't know why. So even though we're not in a Kaggle notebook here, I did switch over to using Face instead here, and it's been just as good as Chroma, if not better. So that's the only reason why I switched over here. And this kind of doesn't matter as much. We'll talk about. We'll get to indexing when we get to indexing. But the other thing I want to call out here is the semantic chunker. So we did talk, or in a previous stream when we built a very simple RAG pipeline, we used the LangChain text splitters here to do a very simple chunking. Yeah, so what the semantic we'll get around to what the semantic chunker is, but basically I just want to call it that this is the other new piece. If you have been following along with the streams to date, everything else in here we have done before, or we have used before. I just copied and pasted all of this in just because there's a lot of typing and we want to get to the good stuff quickly. Okay, so I do have my data set saved locally. However, I do want to call out that I did I do have them here on Kaggle. So this is one I want to call out here. So there's actually 2 data sets here that you can make use of. So the first one here, this is our synthetic knowledge items. So basically what I did is using GPT-4o, I simulated what a corpus of knowledge items might look like. So just as a reminder, so most companies out there, if not all companies, if you're in a large enough IT organization, imagine you got like a call center of folks that are helping people out through their IT related issues, like how do I reset my password, or how do I do this, et cetera, et cetera. And as these new people come on board, it is not fair to necessarily expect that they would have all that knowledge. So the way that most companies curve around that is by creating a knowledge article base that has all these different knowledge items within it, and within each of the knowledge items, I'll say, okay, here's the step-by-step instructions for how to do whatever it is that you're wanting to do. Reset the password, whatever. So that's what this one is. This contains 100 different items that I simulated. They're all very generic, nothing proprietary to any company. And then what I did with this secondary set, so this is the new set that we've now worked with, and I'll show it here within the Jupyter Notebook as well. I took 10 of these different knowledge items with the full text from the knowledge item text, and then simulated a question around it, like a standard question that you might receive based off that knowledge item, and then using that full text, I simulated an answer to that question. And so what I'm doing here is I'll even just show it. So basically, we have the knowledge item, the text, the sample question, and then I created what I call the sample ground truth. So keep in mind, with the RAGS framework, if we want to get the most value out of it in terms of using as many of the metrics as possible, we need to have a ground truth. So obviously this is not a real ground truth because I'm not working in a real context. I just simulated one, but we are going to use these 10 different values as ground truth. Now, I will say before we get into this here really quickly, the experimentation that we're going to be doing got surprisingly expensive surprisingly quickly, and so we're going to be really careful here. And when I mean surprisingly expensive, I mean just for a little bit of context, like most of the time when I do these streams, I may be spending, I don't know, somewhere between 20 cents and 25 cents for the API usage. So I'm using like the OpenAI API for my work here. At the end of my work here, like when I did one experimental run, which we'll show what an experimental run here is in this case, I spent $5, like a solid $5. So we're going to be really careful on what we're going to be doing here. And yeah, and then we'll put curbs around like how you can kind of manage these things. But that's the one thing, I guess, to keep in mind. So as we proceed forward, what I'm going to be showing today are tactics for you to consider, but these are not one-size-fits-all tactics. So keep in mind, knowledge items in particular are generally not that long. They're like maybe a couple paragraphs long. So when it comes to chunking of these, I'm not going to spoil it, but basically like the way that you might chunk these documents would be very different than if you were trying to chunk down documents that were, I don't know, like 20 pages in length or something like that. And we will demonstrate all that out here in a little bit. So let's jump back into our Jupyter Notebook over here. So I do have these already saved in over here. And so like I said, we are going to be demonstrating how to use Cursor as well a little bit today too. So what I'm going to say here is if I hit Command K, and I believe this is Command I in GitHub Copilot, so I can just type in the instructions that I want. I'm going to say load in the CSV file data rag synthetic knowledge items.csv as df KIs in a pandas data frame. So obviously I know how to do that like really quickly, but like just trying to show you the different things that you can do with something like this. So you can see here that is the precise code that I want. So you can see if I run this code, oh, I probably got that file name wrong, didn't I? Items, my apologies. All right, items. All right, so you can see here that it loaded it appropriately. So that one's more of a simple one. So we loaded that. I'm gonna delete some of this out. All right, and then I'm gonna say, in fact, I'm gonna try to be a little bit more ambiguous this time with my question here. I'm going to say there should be another file in that same directory that's called like rag sample QAs or something like that. Can you also load that file as a pandas data frame called df validation? So this is going to be our validation set. All right, let's see if this works out. Okay, I think yeah, we got a little bit of hallucination there. So I guess it doesn't like that. I was trying to be super ambiguous with this. So I guess that's the one thing to be careful of when you're using these things is it's not perfect. Like you will get some things that are not perfect. But you'll see here in a little bit how, like, I hope that I can replicate like what I kind of saw. Okay. All right, so that's the validation set. So the next thing that we need to do is we need to kind of slim down this data set a little bit because we don't need everything that is in the current data set. So we're going to drop df kis dot drop columns equals ki alt ki text, and then in place equals true. Okay, so we drop that. All right, now we need to change some of the here. Let's just look at df validation really quick before we do anything to it. All right, so you can see here that we got our 4 columns. We only need these latter 2 columns, but remember that Rugus wants them in a very specific way, like in terms of how the columns are named. So we need to change this from sample question just to straight question, or just question, I should say. And then we need to change sample ground truth to just ground truth. So the way that we do that, so I'm gonna say, I keep confusing the hotkeys between these different programs. All right, within df validation, drop the columns ki topic and text, change sample question to question, and also change sample ground truth to ground truth. Okay, so I think that's correct. Yeah, I'm just looking at that syntax really quick here, and I'm going to just say df validation. Okay, so you can see that worked appropriately. So I mean, we're getting a little bit basic here. Like, I actually probably would not use like this interface like as it stands to like do some of this code, just because some of this code's a lot easier. It's some of the more advanced things, like whenever we get to actually building like matplotlib tables, like that's where I found like a significant speed up in my time. But you can see here, like I mean, I guess if you're not familiar with some of these things like that I just did here, you could see that we basically just used natural language for programming here. Now, at the end of the day, you definitely need to be able to understand what this code is doing to be able to validate the results for hallucinations or anything like that, as you kind of saw, like where it was like hallucinating the names of these CSV files over here, but like otherwise, it's still pretty good. Okay, so we've loaded in these files, we have prepped them appropriately. So let's go ahead and talk about the chunking strategies. So the first thing that we want to do is so we have this corpus here. Let me actually show it. DFKIs. All right, so we have this corpus of data here. So we have 100 different columns. We have the KI topic with the KI text. The first thing that I guess we need to do is we need to load these in as link chain documents. So I'm going to call this documents equals data frame loader. Okay, I think that's correct actually. Yeah, so that is correct. So as you can see there, I just did a tab autocomplete there so that was another AI thing that we just saw there really quick. So it just like, it does make things go a lot faster, I would say, for sure. All right, so, and then I'm gonna just copy in this one function here. So this is a function that we used in a previous stream. Don't worry about what is doing too much. Basically what's going on here is that like in order to make use of Raga specifically, like I said, it needs to be a Hugging Face dataset type, and so in order to get it into that Hugging Face dataset type, there was not a native functionality that actually did that. I actually had to build this little custom function to be able to do so. So not a big deal. But yeah, so all right, so here's where things are going to get a little bit interesting. So like I said, we want to be able to test out different chunking strategies. And so what I mean by different chunking strategies is, so we have here, let me just pull out one of these at random, or just not one at random, but just one of like the first one here. So dfkis.iloc 0, and then ki text. Well, that didn't print out well, did it? Okay, but anyway, so you have this whole massive bit of text here. When it comes to chunking, like basically there's like a lot of different ways we could chunk this thing down, and a lot of them are relatively similar. And when I mean relatively similar, it's just like, okay, how do you want to delimit this thing down? Like, and when I mean delimit it down, I mean, so the most popular one is just by number of tokens. Or I guess not most popular. Well, I guess it is most popular, but it's the most easiest to understand and the most like standard. It's just saying, okay, we want to break this document here into things that have, I don't know, 100 chunks. So we only want 100 chunks here per each of the, or 100 tokens, I'm sorry, per each of these chunk, or 500 tokens per each of these chunk. So that's probably the most simple. And then the other thing that you can also do with that is you can do what they call an overlap, meaning that like, okay, and I think I demonstrated this in one of the previous streams where like you could actually set an overlap of like 20 tokens to where like, okay, if I have one chunk over here that's got X many tokens, then the next chunk representing the next bit of block is still going to have this little overlap between the two chunks, if you will. So we're not going to talk about overlaps today. Like basically what I'm trying to build here is like, how do you build a framework around testing these different sorts of things and then like being able to display them out and whatnot. Or display the results, I should say, and then be able to evaluate that. And again, so this is going to be a little bit of an art. This is not, so what we're going to do today is going to demonstrate the value of chunking strategies for my specific use case here. Whatever your use case here is different. So don't expect that necessarily my end results here are going to necessarily work the best for you. Okay, so what I'm going to do here is I'm going to say, all right, I want to test out a number of different chunking strategies to see their effectiveness. Please use face as the vector store. Please test out please store all the results of each experiment in a data frame called df chunking results. And what else do I want to do? Please ensure everything is done in LangChain. See the imports done in the first cell of this notebook. Okay, so this is where kind of the magic started to happen for me. So I'm not expecting this to be perfect, but it's going to get pretty close. Okay, so all right, this took a little bit of a different path than it took for me the first time. In fact, I'm going to see what happens if I regenerate, or can I regenerate this? Well, I mean, this is not bad though. And in fact, I'm kind of curious what happens just running these. Here, let me go ahead and review the code here to see what's going on. All right, so because I don't know what the difference between a character text splitter and a recursive text splitter is, to be honest. Yeah, I think I'm just going to run with this, though. So let's just review this really quick. So it's doing some imports. It's setting my embeddings appropriately. Oh, that is the one other thing I forgot to do up here. I forgot to load in my my stuff, my API keys. So I'm going to do with open keys / API keys .emls file. Yeah, so you can see Okay, so I just set my OpenAI API key that is stored within this file over here, excuse me, as the environment variable. Okay, so if we were to run this, I believe, okay, hold on. I'm gonna grab these. All right, so one thing that I just noticed that this did not include was the results here. All right, so I'm gonna go in here. Please refactor this to check for validation using Ragus. I specifically want to use the following Ragus metrics, or I guess the pasted Ragus metrics. The validation data set is in df validation. It probably needs converted first using my custom pandas to Ragus to Ragus function. All right. Okay, so it's doing, so it has the tendency to want to do this as well, where it adds some things. So you can see, I guess the thing I want to highlight here is, so this is what we call like diff view kind of thing. So this is, so basically what it's showing is, okay, so the current code you have here is in red. I want to replace this red code with the green code. Yeah, so that's basically what it's doing here. So let's go ahead and accept this. All right, so let's go ahead and walk through this just to make sure that this is all correct. Oh, I guess the one thing I should say here is it didn't take into account like the fact that I like to, here, this is gonna bother me. Please ensure all annotated comments start with a verb that ends in ing. This is just a personal preference, does not matter. Okay, so you can see that it's changing all that now for us. So you can kind of see now that like one of the really great things about using code editing tools like this is like you can really seamlessly add annotated comments to everything, which I personally do anyway. But now it makes it a lot easier for people who are not as inclined to want to be able to have to do that. Okay, all right. So we have our chunking strategies. We are setting a chunking results thing, so it's going to be the strategy, the number of chunks, average chunk size, faithfulness, answer relevancy. You know what? I want to add another one here. Uh-oh, didn't mean to do that. All right, so add another chunking strategy to use the semantic chunker. Okay. Okay, so this is actually gonna look way different than my code that I actually have. Well, not way different, but a little bit different than the code that I have shared on GitHub, and I'll show that here in a little bit, just to show like, because I wasn't planning on doing chunking strategies, but hey, I mean, or I'm sorry, overlap strategies, but hey, if they're gonna recommend these results, we're just gonna run with them. All right, so I just want to walk through this to make sure that everything looks fine. Okay, so again, we are setting up our results. We are converting our validation data set as such from using our custom pandas to Ragus sort of thing. And then, oh, son of a gun. I think I screwed something up here. Okay. I am forgetting something in here. All right. So yeah, I'm still getting used to using code, things like this because I wanted to produce an answer as well. Okay, so I'm going to just copy and paste some stuff in here. All right, so I'm going to create. All right, so I'm going to create I have a prompt here that is creating like an answer based off of the question, because again, we want to be able to assess this with Ragus. And then I want to set up a couple of other things in here. All right. So that is this. So this is all, the reason I copied and pasted this is it's all nothing new. So basically what we're doing in here is we're creating a little bit of a chain that's going to use this to be able to answer questions below and generate it. So what I'm going to do here is I'm going to reselect all this, refactor to use the answer generation chain to be able to answer the question from within df validation to produce an answer. The answer needs to be saved back to df validation as answer before it gets converted into the Ragus test set. Okay, so let's see how this does. All right, so far no changes, which is no surprise. Okay, so there's a little bit of a change right there. For index row, where are we getting these? Yeah, this is not correct. I don't think this is correct. All right, so df validation net. All right, response.content. The problem is that though, like it needs to, yeah. Okay, I don't like any. I'm starting to get a little bit confused, and like I normally wouldn't care, and I would just keep going. But like I gotta get out of here in like 30 minutes, so we gotta move things along here. So basically what I'm going to do is I'm going to copy and paste the code that I used in yesterday, but you can kind of see like, so this was my, I mean, this was all still really good. Like this is, you could see how fast we just built like a simple pipeline. Now, is this perfect? No. Would I have to go back and like refactor it and I could probably refactor it in like 20 minutes, and 20 minutes is not that long, but when you got to get going, to do other things for the day, this is not going to work. So I am just going to copy and paste this code in. All right, so let's walk through what all this code is doing then. For chunk size and chunk sizes, oh, I forgot that I did this as well. Hold on. It is hot in my office. Okay. All right, I want to remove this because I don't want to do that necessarily. Okay, so now let's review this code here instead. So I know, because I can guarantee this code works. All right, so we're loading in our documents using LangChain. We're setting a number of different chunking sizes, including the semantic chunker. Now, to be completely honest, I'm not really sure how the semantic chunker like actually works under the hood. Like basically the way I understand it at a high level is it's basically trying to, it chunks things down and then it tries to do like some sort of similarity embedding score, which is why we have to pass in an embedding algorithm there. And then based off of that, it basically tries to produce the ideal results as such. So what we're going to do here is we're going to run this cell and then well, let's keep walking down what this code's going to do. All right, so we set up our chunks. We set up this thing. Yeah, so initializing the results data frame. All right, so we have we're storing our results within this data frame here, and then we're iterating through each of the chunks. So basically, all right, so if we have the semantic chunker, we're going to set up the semantic chunking. If we do have a like a text splitter, I guess I did do a chunk overlap here, and I did not realize that. So basically, so what the recursive character text splitter here is, it's going to say, okay, I want to based off the chunk size, I'm going to try chunking my things down into chunks that are so we got these different chunk sizes here: 100, 200, 500, 1,000, and you'll see which one performs the best, and it kind of makes sense when you see which one ends up performing the best. And so yeah, so we set up our text splitter. So then the text splitter runs, and then we actually grab the chunk. So this is just taking the chunk, like the pure text chunks here. We have not done any embedding yet. So then the embedding actually comes here as part of this face index. So as we noted before, we are going to be using the Facebook face index for our embedding stuff, and then we're going to store everything into the face index. Then we're going to save this out. We actually don't need to do this step, but whatever, we'll keep it here. Then we're going to turn this into a retriever, and we are going to grab just the top one chunk here. And this is another thing that I'm struggling with a little bit, to be honest, is like when it comes to testing out the full end-to-end thing, it's really hard to know like what is the balance of getting everything right. And when I mean the balance of getting everything right, I mean, so we're doing a chunking strategy right now, but it may be that like the actual the best bang for your buck is in terms of optimization of your performance comes from like the retrieval tactics. And so trying to know like how do you turn those how do you turn those knobs to get the most ideal results? Like if I turn the chunking knob, is it going to affect my other retrieval advanced order knobs? That is a very difficult thing I'm trying to wrap my mind around. And to be honest, I don't have a clean answer to that. So this is going to be a little bit naive then. So all of our results are going to be based off of the fact that we're just grabbing one chunk. You would get totally different results if you grab two chunks. And we'll probably talk about yeah, we probably will do a special stream, because I want to do a special stream on why you need to be careful about how you index your data anyway. And in fact, let me come back over here really quick, because you might be wondering if you've ever looked at this data set over here. You'll notice I have, and we dropped this from ours because we're not using it today. We have the KI text, and then we have the alt KI text. And if you're wondering, well, what is the difference between these two? It's kind of hard to see this, but basically what I did so we have our standard KI text, and then I generated an alternative set of knowledge item text based off the topic, except I purposely forced in there, you have to, I don't even remember what I said in there. You have to include like a specific company name in every single knowledge item there, which is like, so the reason I say that can be a problem. So like, let's say you're a large organization and you are managing like this is going to be a really bad example. You're managing the IT staff for your marketing department, and you're managing the IT stuff for your I don't know, your sales department, and each one of them has like different knowledge items, but for each of these topics, but they're very similar. So if you were to go and index all of your KIs and all your alternative KI text within the same vector index, and you don't have them like managed with tags or anything like that you could parse that out, then you have a problem on your hands, because then you could be getting like a semantic similarity based off of the alt KI text. So I'm deviating because I want to cover this in another stream to kind of harden this. And I apologize. My daughters are going wild upstairs right now. So if you hear them running around or screaming, they're just having fun upstairs. It's all good. Anyway, so coming back to the cursor code here. All right, so so this is where we left off here. So basically we're using the context here that we retrieve from we are using this context here to retrieve the page content per the question. That's what this little lambda code here is doing. Now, the one thing I kind of like about these like AI assisted tools in Cursor is it's really good at writing Lambda functions. And to be clear, Lambda functions in Python are very different than AWS Lambda functions. They're two totally different things. Basically, Lambda functions in Python is a shorthand way to write a standard function without like the whole def sort of thing. And as a note, yeah, it does a fantastic job here. Like, I don't think I would have written my code this cleanly, to be honest. Okay, so we are getting the context per the question from the vector store, and then we are using the context that we just retrieved to answer the question, and then storing that as answer before we transform that into our Ragus test. Now, let's pause for a second here because I want to be very clear on what this is doing. Yeah, so let's jump back up. So we're basically filling in this prompt here. And so what it's saying is, so this is a standard prompt. Like there's nothing particularly fancy in here. This is something that you might want to alter for yourself as well. This is just another one of those optimization tactics. Again, trying to twist these different knobs to find your optimization is really going to be up to your specific use case. And I'm giving you the best framework I can give you to try to help measure that, but it's still a challenge at the end of the day. Like, at the end of the day, the best results are going to come from however many different combinations you can experiment with. However, as I noted, the more you experiment, the higher your costs. Okay. All right. So yeah. So anyway, so we're answering the question. Let's come back on down. We are converting this validation data set into the Regus test set using our custom pandas function. Then we are using Regus to actually be able to generate the metrics. So we're only going to be, I think Regus has something like 11 metrics. We're only going to be doing 5. Now remember, it's 5 for, like, we're evaluating 10 different questions, which means that we are evaluating 10 times 5, or we're evaluating 5 of these metrics times the 10 questions. So that's 50 invocations times the number of experiments we're doing. So we're going to do 5 different experiments here, one with each of these different chunk sizes in the semantic chunking. So what is that? So that's 5 times 10, that's 50, times another 5, that's 250. That's 250 API calls. That is why I'm spending so much money on these different experiments. And this is, like, in my opinion, this is a rather simple experiment. Like, I'm only using 100 different KIs or sample records. I'm only using these different number of chunking strategies. You can imagine, like, your bill can get very high very quickly. Now, I guess I should say the one thing, like, I'm being a little bit bougie here in the sense that I'm using, where is my model? Where's my chat model? I know we instantiated it up here somewhere. Oh wait, here it is. So I'm using GPT-4o latest. If I were to use GPT-4o mini, I'm sure I would reduce the cost. But this is the latest and greatest experimental model, this ChatGPT-4o latest here. So we're gonna stick with that, and yeah. So let's go ahead and run this, because this, I guess I should have had this running anyway. In fact, I'm going to restart, clear all outputs, and run all, just to get it all going from scratch. All right, so hopefully we don't have any problems here, because sometimes, well, I guess I did copy and paste this code, so we should not have any problems. So this will take just a minute. And then I'm actually just going to go ahead and start copying and pasting this other code in, just to show, because I gotta be honest, I'm not feeling great right now. Like, I'm starting to feel like, I don't know, maybe, so yesterday was my birthday, and I had a lot of sweets and stuff, and I got a little bit of a stomach ache now. So I'm gonna try to bring this stream to a close sooner than later. I'm doing okay. I'm just feeling a little bit weird right now. So so there like this is the bulk of the stream, but I do want to cover one other thing. And I think I'm just going to display it because I'm feeling funky right now. All right, so this is going to take a bit anyway. I guess the one other thing that I want to show here. All right, so basically when this all completes, we're going to display this out as a table. This was all generated using Cursor code. Like, this was by far the fastest thing I've ever done. So usually trying to do something like, I love Matplotlib. It's just it's, I don't want to say hard to work with. It's just cumbersome to work with, like, especially trying to get all the syntax right. So the fact that, like, it generated this code in like 0 time, like, was amazing to me. All right, and in fact, I'm gonna go ahead and start loading up the other thing, because the other thing I want to talk about is the value of indexing. Okay, I'm just gonna display my GitHub notebook over here. Yeah. Okay. Ingestion. All right, so this is basically the same notebook that we're walking through right now. The same sort of information, and then we'll come back to this when this is done. So this might take a bit. Actually, we're gonna skip. So given that this is gonna take a little bit, we're just gonna we'll come back to this part, but just keep this in mind now. So the other thing I want to talk about, and this was actually a little bit harder to demonstrate, was the value of, like, indexing using an indexing algorithm. So what do I mean by this? I mean, so what we're doing here with these vectors is that we are creating these vector embeddings, and then we are storing them into a vector database. And so these are just, as a reminder, a vector embedding is just like a really long series of numbers. And then we are doing something called a cosine similarity, or an approximate nearest neighbor similarity, some sort of similarity score that's taking these two vectors, doing a mathematical comparison, and then getting, like, the most popular one of them. So the reason like that I found this a little bit hard to demonstrate was because that most, if not all, vector database options have some sort of indexing already built in them. Most of them actually use this special indexing thing called the hierarchical navigable small worlds algorithm, HNSW for sure. And so, like I said, almost all of these, so you can see here, Pinecone, Weaviate, OpenSearch, Chroma, Face, they all have some sort of indexing algorithm going on underneath. So what I did is just to show like the value of doing that from a time perspective is I took all of the 100 documents, embedded them, stuck them into a face index here. So that's what this is doing here. Now, if we come on down further here, then with this next one here is I just did an embedding on each of the 100 documents and then just stuck them in a standard Python list. This is just a standard Python list, nothing being applied to it. And then so actually this was all code that was very, very simply created using like the cursor code, autocomplete kind of stuff. And so what I did here is I just wanted to see how long it took for the standard list retrieval versus the face retrieval time. And I guess the one thing I should call out here is this is probably not the best example, because you might be looking at these numbers and saying like, yeah, face is faster, but like it's not that much faster. Keep in mind, we only had 100 documents here. So like if you have like 1 billion documents, I would actually expect it to be like it. So if you understand big O notation, I would expect like the face retrieval time to be more like a log n retrieval time, meaning like as you comb through more of your documents, it just gets faster and faster and faster and faster because of that HNSW. Whereas like a standard retrieval would be more like a straight linear time. And so just to highlight that, so if we go to desmos.com/calculator, so basically I'm doing y equals x versus y equals log of x. So you can see here, so as time goes on, imagine this red line being like the linear kind of retrieval, whereas the blue line here is more of this logarithmic retrieval. Okay, so that's the average time. And then when I plotted them out, so you can see here that, so the face line represents the time in seconds it took to grab or to get the appropriate document chunk for each of our questions. So you can see here, with the exception of question number 9, I apologize, my face is kind of in the way there. Excuse me, with the exception of question number 9, which the standard list was actually faster, face still was faster than all those. So like I said, not really too much to cover here, because it's not as it, like, depending on the vector store that you end up using, whether it's Pinecone, Weaviate, OpenSearch, or whatever, this is already going to be built in, and there's not, in most of these don't even have like the ability for you to alter necessarily how that works. So I think OpenSearch, for example, I think it forces you to use HNSW, which is fine. Like the benefit from using one of these indexing algorithms is not necessarily performance. It's more so around fast retrieval speed, which is still extremely important. Don't get me wrong. It's just that like it's not like you're going to necessarily get a better performance per se from doing something else here. All right, so we have already made it through 3 of our experiments. So let me actually just go into my personal AWS or my personal OpenAI account, and we should start to see an increase or an uptick in my billing here. Okay, I always forget where to check it. This here. Where is it? I know it's in here somewhere. All right, dashboard, usage. Okay, maybe this is it here. Default project. Okay, so that is that's the default project. Okay, so this, I guess it's called Kaggle, but like this, so this is my algorithm. So you can see that today I've already spent, so I have not done anything else today. I've spent $3.43 so far on all this stuff. And you can see, wow, it's actually kind of interesting how, oh, I wonder if I'm about to get rate limit, or if I'm about to hit my threshold here, increase my limit. I better increase my limit to 20, save. I probably just got an email about how I spent too much. We'll see if this continues on. And if not, I've still got the notebook that we could share in the other space here. Okay. So we are just about at the end here. Basically, just this is all I wanted to wrap up, showing like how this kind of works out, and we'll talk about why the results are why the results are why I think they are. Does that that probably makes zero sense? Why the results are. Yeah, apparently I'm just not thinking straight this morning. Okay, but it's almost done here. And again, you can also kind of see why like it takes a long time to do some of these experiments. So my recommendation is if you do your own experimentation, most of these corpus of documents that you're going to be working with, you're going to have more than 100. I'm only working with 100 here. You're gonna have to probably be a little bit strategic on how you do this. Like, so let's say you have like 1 million documents in your knowledge base. In order for experimentation purposes, you're probably gonna have to slim that down. Otherwise, like if trying to run an experiment on 1 million documents like I'm doing here, probably just is gonna take forever and just be way too long. And I don't know if I'd advise that. So your results may vary. So all right. So we've already completed 4 of our things here, or 4 of these things. Yeah. So by the way, I just want to give a little bit of heads up. So the next stream, I already do have a plan for the next stream. It will not be a reg stream. It's actually going to be a little bit of a non-AI stream. And that is, so yesterday I discovered GitHub code spaces, and I am extremely excited about GitHub's code spaces. So actually, yeah, let's talk a little bit about Cursor and why I probably won't stick with using it. And to be clear, I do think it is still probably like the ideal platform. So you might be wondering, well, why would I not want to go with the most ideal platform here for AI coding assistance? And that is, I try to keep my stack as consistent as possible. And what I mean by consistent as possible is, I mean that like, so I work with certain tools at work, I work with certain tools at home, and I would like to not have to deviate between them too much. And additionally, the other thing is that like so you may have seen my blog post yesterday where I talk about how I like to prefer coding on an iPad. So basically all signs point to that like GitHub Copilot is probably still the better fit for me. And again, this is just for me. And the reason that is because, and this I'll demonstrate in this next stream, within code spaces, you basically get 60 free hours a month or 80 free hours, depending if you're a GitHub Pro user, to have basically like a cloud version of VS Code that you can also enable with GitHub Copilot. Now, to be clear, if you want to use GitHub Copilot in the code spaces, you do have to have a subscription, and that is $10 a month. And that's the other thing is Cursor, if you use Cursor Pro, is $20 a month. And so basically, like, again, Cursor today is still probably the better choice. But for me in particular, given that my workplace uses GitHub Copilot is a better fit for my iPad use, that's probably what I'm going to go with. And I'm also kind of banking on the fact that GitHub Copilot is just going to continue to get better from here. You know, you never want to bet against the big guy. Okay, so all right, this is done now, finally. So let's go ahead and display the results out here. All right. Can I move my face? All right, well, you can't really see my face, but basically this last set of ones here is the semantic chunk. All right, so what do we see here? Basically what we see here in general is as we increase the chunk size, we actually see an improvement in results. So this is actually where I am not surprised at all. And the reason for that is in the context of working with knowledge items in particular, generally speaking, it's not as if you can just use a chunk of that knowledge, a chunk of that knowledge item to answer the question. Generally, you need the full thing to answer the question. So it doesn't surprise me that these higher chunks work out better. In fact, I would actually say maybe for these knowledge items, you don't chunk them at all, and you just inject them directly. And again, it just goes back to this idea that as we can see via the results here, like the results are pretty Like you could, especially the answer relevancy and the answer correctness. I would say those are probably the two most important. Although I would say answer correctness is a little bit low on all of these, but the context precision, like generally speaking, with all these other metrics, you can see that we're performing better with the larger chunk size. And again, this is going to be very different. Like if you are working with legal documents that go like terms and conditions documents that can go like 20 pages upwards, and you want to be able to ask questions of those, it's probably better to have some sort of mid-range chunk size, something that's like a 500 range chunk size. I don't know. But for these knowledge items, it does not surprise me at all that having a larger chunk size, or even not, I didn't even check not chunking them. I should have tried not chunking them to see how they did, that it would perform better. Okay. And so, but again, I have to reiterate, this is just one knob we can turn, one dial we can turn. In the next stream, when we cover advanced retrieval, those are going to be other knobs that we can turn, and trying to balance those, trying to know, okay, if I change my chunk size over here versus changing this retrieval tactic over here, am I going to get the most performant results? That's hard. That's really hard to answer. And I'm going to do more research on that. Maybe there is probably a better way to think about that. And I'm just not thinking about it super clearly right now. But anyway, that really covers ingestion. There's not really much more that you can do on ingestion. Like, yes, so in terms of chunking, we did like just a straight like number of tokens chunk. You can also do chunks based off of paragraphs. You can chunk by sentences. If you are working with an HTML documents, you can chunk by HTML tags. There's all sorts of chunkers out there. In fact, let me go into the LangChain documentation just to show you the text splitters. So integrations. Let me just Google it. LangChain text splitters. Oh yeah, it was doing that to me yesterday too. I don't know why it was doing that. Well, document loaders, LLMs, tools/toolkits. All right, well, apparently I'm not going to be able to find the text splitters really quick, but basically there's a bunch of different ones out there, especially offered by LangChain. All right, we are coming up on the end. Any last minute questions or anything? Because I'm feeling a little bit better, but yeah, I still need to get out of here soon because I guess there's some parade here in town. My kids want to go to it, so we're probably going to end up going there. So if you live in Bloomington and you're going to be in downtown Bloomington, you might see me around, maybe. All right, we're going to head and wrap up for today then. All right, I hope you... Didn't mean to do that. Sorry. I hope you all have a great weekend. Like I said, so this coming Friday, I am going to target another live stream. It is going to be a deeper dive around the GitHub code spaces and then the GitHub Copilot integration because I'm really excited about that. So that has nothing to do with RAG or really AI ML, if I'm being honest, but it's still something I'm excited about. So that'll be the next stream. We will definitely come back and do some of the advanced retrieval tactics, and I would eventually like to do another stream around RAG with graph databases. And to be completely honest, I don't know much about graph databases, so I probably need to go out there and learn about Neo4j or something like that. But we will eventually get back around to that. So hope you all enjoyed the stream, and I hope you all have a great rest of your Labor Day weekend. Thank you.